Question states, calculate the delta H of reaction, the enthalpy of reaction for the formation of ethanol, given 3 separate reactions and their associated enthalpy of reactions. We already went over method A, which is dealing with the formation. There's a second method. That's going to be method B. In the second method, we're going to be using what I call the sum it up method, meaning we want to have all of our individual reactions and the reaction in question in agreement. So when we identify graphite, H2, O2, and CH3OH, we want graphite represented in the individual reaction as a reactant, because in the main reaction in question, it's a reactant. We also want H2 as a reactant, we want O2 as a reactant, we want methanol, CH3OH, to be represented as a product in our individual reaction. So let's go to reaction number 1. In this reaction, we have methanol in common. So methanol needs to be a product as per our reaction in question, and it is currently being represented as a reactant. So we need to reverse this reaction. So we want to rewrite this reaction in reverse so that methanol is represented as is represented in the reaction in question as a product. So to do that, we will now have CO2 plus 2 H2O, yielding methanol, the CH3, or I said ethanol, I meant ethanol, CH3OH plus 3 halves O2. If it makes it easier to think of 3 halves as 1.5 O2, by all means do that. We reversed it, so we need to reverse our side. In the next equation, we have graphite, O2, and CO2. Graphite is a reactant in the reaction in question. It is a reactant in this equation, so we are going to leave it as is, not change anything. We have 1 graphite. We have 1 mole of graphite in the reaction. We have 1 mole of graphite in our second equation down here, so we don't need to do any manipulation to it. We can leave it as is. The third reaction has hydrogen and oxygen, which we also have hydrogen and oxygen in our initial reaction. It is being represented as reactants in our reaction in question. They are reactants in the reaction below. The only thing we have to worry about is the fact that we have 2 H2 molecules. So we wanted to manipulate the bottom equation to have 2 H2s. So we're going to double everything. We double a half. And by doubling 1 half, we now have 1 O2. And we also want to double H2O. And by doubling that reaction, we need to double the enthalpy, since we now release twice as much heat. So we multiply this by 2, and we have the 571.6 kilojoules of heat released. It's going to be negative still, since we did not reverse this reaction. Based on method number 2, it's called the sum it up method, because once you place all substances on the same side as the reaction in question, there's no products minus reactants. That's only for the formation method, method A. You simply sum up all of your values. So you have a positive value, a negative value, and a negative value. Add everything together, and you're going to get a total value of 238.7 kilojoules of energy. Now this is the same, you're going to get the same answer as method A and method B. If you decide to do both methods and you got different answers, you did something incorrectly in one of the 2 methods. The one nice part about method B is that you can go back and actually cancel out substances that are found in both reactants and products. By that I mean CO2. CO2 is on the reactant side, it's also on the product side. 1 mole on the left cancels out with 1 mole on the right. H2O. We have 2 H2Os on the reactant side. We have 2 H2Os on the product side. They each cancel out. The CH3OH is only on the reactant side, not on the product side. It does not cancel out. You have 1.5 oxygens on the product side. You have 2 oxygens on the reactant side. So what does that leave us with? 1.5 take away from 2? Well, that means we have half of an O2 molecule. So half a mole of O2 on the reactant side in total. We also have graphite on the reactant side that's not canceling, and we have two H2s on the reactant side that's not canceling. So if we rewrote the equation and removed everything that is on both reactant and product side, we would have carbon, that's graphite, plus two H2s, plus 1/2 O2, yielding CH3OH, which is the same as the reaction in question, which proves we correctly manipulated everything.